Hi, my name is Justine Harkness, and in this video, we'll look at how to use Kirchhoff's node rule to determine how current will split when passing through resistors in parallel. Whenever we have a node in a circuit, and a node would be just somewhere where our current is going to branch, Kirchhoff's node rule states that the current flowing into this node has to be equal to the current flowing out of this node. And this is because anytime we have a circuit, the amount of current leaving the battery has to be equal to the amount of current coming into the battery on the other terminal. So we can't lose any current throughout our circuit. So therefore, we cannot also lose any current as we go through these nodes. In essence, the node rule is analogous to the law of conservation of mass. Just like we have to conserve mass in circuits, we must conserve charge. Now, if we have resistors wired in series, the amount of current flowing through each of those resistors is equal for that same reason. We can't lose any current in our circuit. However, if we have resistors wired in parallel, the current's going to be split between those two resistors. And the amount of current flowing through a resistor is inversely proportional to its resistance. Let's look at an analogy to see how this works. So say we have a mountain where it's really steep on one side, but not very steep on the other side. And we're going to go skiing. We're going to open up our own ski resort. So on the one side that's really, really steep, this would be like a black diamond. It's very hard and it has a lot of resistance. On the other side, our slope is pretty gradual. This would be like a green circle, which is pretty much meant for everybody, regardless of skill level. Now we're going to have our skiers go up our mountain through our ski lift, which is like our battery. Once we get to the top of the mountain, we have to make a decision. Do we want to go down the black diamond or the green circle? This is just like getting to a node in a circuit where we have to choose between either path. But only the best of the best will have the guts to go down that black diamond. So this would be very few people who would go down this path. However, that green circle is pretty easy. There's not a lot of resistance to our decision to go down that pathway. So there would be a lot of people who would go down that green circle. And the same thing is true with current. When our current goes up our battery and gets into a point where we can go in either of two directions, if we have a high resistance, there's going to be very few charges flowing through that path, very little current flowing. However, if we have low resistance, there's going to be a lot of current going through that pathway. You may have heard the phrase, current likes to follow the path of least resistance, and that is exactly what we see with our node rule. This figure here is just diagramming what a node would look like in a circuit where we have our current coming in, our current coming out. And notice our current I1 going in is equal to the sum of I2 and I3, or a current going out. Now let's take a look at some practice questions. So here we're given a circuit diagram and asked to answer a few questions. The first thing we need to determine is how much current is leaving the battery. Now the first step to answer this is to calculate the overall resistance of our circuit. A quick analysis of our diagram tells us that R1 and R2 are in parallel. So we're going to use our formula for resistors in parallel. 1 over R total is 1 over R1 plus 1 over R2. So we'll plug in our values, 1 over 5 plus 1 over 15, and this would give us 0.27. Now notice that's 1 over our total. We'd have to take the reciprocal to determine our resistance. So 1 over 0.27 is equal to 3.7 ohms. Now we can use Ohm's law. So V is equal to IR. So that means that our current is equal to our voltage over our resistance. Our voltage here is 10 volts. We can plug that in. Our resistance is 3.7 ohms, and this would give us a total current of 2.7 amps. Now let's take a look at part B. This is asking how much current is passing through R1. So remember, our current leaving our battery that we calculated earlier is 2.7 amps. Whenever it comes to this node, it's going to split. And we need to determine what the current is going through our first resistor, R1 here. So to do this, we keep in mind that the current is inversely proportional to the resistance. So if we look at R1 to R2, our resistance ratio here would be 5 to 15. This means if we were to look at the current, remember it's inversely proportional, that means that we essentially just flip this ratio. So it would be 15 to 5. And if we simplify that, it would be a 3 to 1 ratio. Now note this is a part-to-part ratio. That's the current going through R1 relative to R2. So we need to convert this into a part-to-whole ratio. So the sum of our parts would be 4, so 4 total parts. So that means that for R1, our part-to-whole ratio would be 3 to 4, which means that 3/4 of our total current is going through R1. So if we say 3 over 4 and put in our current of 2.7, this would give us 2 amps. Now, part C asks us how much current is passing through R2. Well, if we know that there are 2 amps passing into R1 and coming into the node, there are 2.7 amps, the current going through R2 would be equal to the total current minus those 2 amps going through R1, which would be equal to just 0.7 amps. Now, I will say there's another way that we can calculate this using the loop rule. Because remember, for any loop, the voltage drop across that loop has to be equal to the voltage drop of the battery. So if we consider our loop that contains R2, we could say our voltage drop across this whole thing has to be equal to 0, which means that our voltage that we gain going up the battery has to be equal to the voltage drop across R2. So remember, V is equal to IR. So we could say 10 is equal to our current going through R2 times the resistance of R2, which is 15 ohms. So our current going through R2 would be equal to 10 volts divided by 15 ohms, which is also 0.7 amps. Note by using the loop rule, we can actually get a little bit more precise of an answer. 10 over 15 would be exactly 0.666 repeating. We did do a little bit of rounding here, as well as doing some rounding when we used the node rule. So really, which method that you use can depend on how precise you want to be with your answer. So there's a couple different ways that we can solve these problems, but it's important to be comfortable with both. That way you can handle anything that your physics professor throws at you. But now you should feel more comfortable using the node rule to calculate the current whenever we have a split or a node in a circuit.